Okay, I'm going to do a couple problems here on 447. These are the word problems. Essentially, I'm just going to draw the pictures and have the setup. I'm not going to actually go through the answer. I'm going to assume that you understand how to use sine, cosine, tangent. Here's number 11 on page 447, meteorology. A meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1503 meters from his location to the nearest meter. How high above the ground is the balloon? So we're going to try to draw this scenario and then put these important numbers as well as X in the picture. So you got this weather balloon up here. We're going to assume it's in the sky here. And here's the ground. Here's a guy here. Boop, boop, boop. He's got some type of machine that can pick up his location of the balloon, and it picks it up, and it is 1503 meters from the balloon. That's not really a string, it's just a radio signal. Okay, the angle of elevation is 41 degrees, so it picks up the balloon at 41 degrees, and then the question says, how high above the ground? How high? Now, again, once you have the question, that's your X. So how high above the ground? Of course, X would not go here. It would be straight up and down X. This is the horizontal distance. This is vertical distance. So there is your right triangle. Hopefully you can see it here. Oops, that's horribly drawn. But ultimately, stand at the angle, opposite hypotenuse. So you would say sine of 41 is equal to opposite over hypotenuse. Whenever you're doing these word problems here with angle of elevation, angle of depression, expect to see a right triangle. Okay, I'm going to do number 14 here on 447. Let me see if I can zoom in here. Indirect measurement. Miguel looks out from the crown of the Statue of Liberty, approximately 250 feet above the ground. He sights a ship coming into the New York harbor and measures an angle of depression of 18 degrees. Find the distance of the base of the statue to the ship drawn to the nearest foot. Okay, so the key numbers here are 250 feet above the ground, angle of depression, how far is the distance from the base to the ship. So you got to know that there is a statue here. It's a Lady Liberty. This is my horrible rendition of the Statue of Liberty. And Statue of Liberty is on an island, and of course that means there's water. And there's a boat out here. And Miguel is standing on top of Lady Liberty's head. So there's a guy up here, Miguel. And he sees an angle of depression, sees the boat at 18 degrees. So an angle of depression means you look straight out, the horizontal, and then looks down and sees this boat. The angle of depression is right here, 18 degrees. It is not here. Sees the boat and looks straight down. The angle is formed by the horizontal and the line of sight. The 250 feet above the ground, that is the height of the statue. So this statue here is 250 feet. 250. And then the question is, we'll find the distance from the base of the statue to the ship. The base of the statue is the bottom to the ship. So this will be X. Hopefully you can see the triangle here, the right triangle. And with this right triangle, the 18 degrees is not currently in the yellow triangle here, but the horizontal and the base here, they are parallel. So if it's 18 degrees up here, it's also 18 degrees on this corner. Okay. You could say this is 72 degrees because it's 72 plus 18 is 90 degrees, but ultimately 18 is down here. Then you set up your equation, you've got opposite, you've got adjacent, so you would say tangent of 18 degrees is opposite the height of the statue over X, the distance to the ship. That's the adjacent part. And then go ahead and solve that for number 14. All right, this is word problem number 15. Flagpole. The world's largest unsupported flagpole is 282 feet tall, steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long to the nearest degree. What is the angle of elevation of the sun when the shortest shadow is cast? So let's try to draw this scenario here. Here are the important informations here. We've got a flagpole here. It's British Columbia, so that's Canada. So There's the flag. There's a maple leaf here. Maple leaf. If I drew it correctly, that's horrible. There is a shadow, and of course a pole is standing up. A shadow is on the ground, so that's the shadow. Let's put some of these numbers in the picture number 15. This is 282 feet. The shadow is 137. Of course, the sun is up here. And then what are we trying to find? We are trying to find the angle of elevation, so that will be x. Now, rays of sunlight go this way, and the way you cast a shadow is it hits the pole, and then it hits the ground. And then this, of course, this 137 is the shadow. You want to know the angle of elevation up to the sun? That's x. Here is your highlighted yellow right triangle. We're going to be at unknown angle x. We've got opposite, we've got adjacent, so we'll say tangent of x is equal to opposite the height of the pole over adjacent the shadow. Okay, and then of course, because it's an unknown angle, you need to use inverse tangent on your calculator, inverse tangent, to get an unknown angle. Number 16 here, engineering. The Americans with Disability Act states that wheelchair ramps can have a slope no greater than 1 over 12. Find the angle of elevation of the ramp with the slope, rounded to the nearest tenth. There's not a whole lot of information here. We know there's a slope, which is unusual, of 1 to 12, and our job is to find the angle of elevation. So let's try to draw this picture here. It is a wheelchair ramp. So we will do this. There's a ramp here. Whoops. This is not the greatest ramp. That ramp's way too steep. Let's go like this. Even that one's too steep. And then wheelchairs would be going up or down on this ramp. This ramp is way too steep because this is like a roller coaster if you're on a wheelchair there. But nevertheless, I drew it poorly. Okay, so where do I put this information? Well, if you'll recall, when you have slope means rise over run. How far does it go up and down compared to how far it goes left to right? So if I have 1 to 12, that means it goes 1 foot up to every 12 foot across, 12 feet across. So really, I mean, this picture visually is poor because this doesn't look like 1 to 12. It would be way more like this, which is 1 foot this way, 12 feet this way. And then wheelchairs can, rightfully so, roll up the hill without killing themselves. So our job, though, that is how to use the slope numbers. Our job is to find the angle of elevation. So that's right here, x. Okay, here's the 90 degrees. There's angle x, opposite, adjacent. Tangent of x is equal to 1 over 12. Again, this is a missing angle, so we're going to say angle x is inverse tangent. You got to use that inverse button in the calculator, 1 over 12. And that will tell you how steep this angle would be to fit within this slope, 1 to 12. And this will be number 17 here, construction. 2 office buildings are 51 meters apart. The height of the taller building is 207 meters. The angle of depression from the top of the taller building to the top of the smaller building is 15 degrees. So if I stand here at the top and I see the top of the smaller one, it's a 15-degree angle depression. Find the height of the shorter building. We've got the taller building. We have an angle of depression. How can we figure this out? Well, let's try to redraw this. Our job is to figure out the height of the shorter building. Basically, what you're going to do is figure out, well, how much taller is the tall building? What is that difference there in yellow? That will be our x. Okay. And once we figure out what x is, and there's a right triangle there. Once we figure out what x is, you take the tall building, which is 207, and then you just minus the difference between the two buildings, which is x, whatever x is, and then that will give you the short building. And that's our ultimate goal there, is to figure out the measurement of the short building by subtracting. Whoops, I'm not on the screen there. So I take the tall building, minus out the difference, which is x, and then I have my answer. But let's look back. How are we going to get x? You can see this yellow triangle here. 15 degrees is the angle of depression. That dot, though, is right here. So this is 15 degrees. This is 51 meters. There's x, you've got opposite, you've got adjacent. So you say tangent of 15 is opposite over adjacent. Whoops, adjacent is 51. I don't know why I put 5x. 51. Calculate what x is. Whatever, as soon as you get what x is, that's the difference in the height between the small and large building. Plug that number in right here, and then subtract it from the tall building, and you would get the measurement of the small building. That is number 17.